When adding and subtracting fractions, you're going to be adding the numerators and keeping the denominator. But before you can do that, you have to make sure the denominators are the same, because the denominators tell you what size your fraction is, or what you can think of it as what type of fraction you have. For example, do I have a quarter piece? Is that the type of fraction I have? Do I have a third piece? Is that the type of fraction I have, etc.? So when we have something like 1/2 times plus 1/4, when we're adding 1/2 and 1/4, what that means is we're taking a 1/2 piece and we're adding a 1/4 piece to it. So what we have to do is convert the bigger piece into as many smaller pieces as is necessary to be able to add all of one type of piece together, or all of the same denominator. So, for example, in this picture, I have 1/2 plus 1/4. Well, 1/2 is the same thing as 1/4 and another 1/4. We all know that, right? And we're adding that to a 1/4 piece. So really what we're adding together are 3 1/4 pieces. And you can see that in the next picture. We have a 1/2 piece, which is the same as 2 1/4 pieces, and a 1/4 piece, which gives us 3 1/4 pieces, which is the same thing as 3/4. The reason I show this visual is to help you understand why we get a common denominator when we're adding or subtracting fractions. We do not do this with multiplying and dividing, as we will get into in that section. So the process of finding the common denominator is going to be based on working with the least common multiple. So let's review that. If we have 15 and 24 and we're trying to find the least common multiple of these two numbers, we're going to find the prime factorization of each. And I showed you guys how to do that using a prime factor tree. However, for some numbers you don't need to do that because the numbers are small. For example, 15, I know that 15 is 3 times 5. I don't need to draw a prime factor tree to figure that out. I know that 24 is 8 times 3. I just happen to know that 8 is 2 cubes times 3, or maybe you're thinking of it as 6 times 4, which is the same as 2 times 3 times 2 times 2, 6 times 4, which equals 2 cubed times 3 as well. So if you have a pretty easy number, don't worry about drawing the whole prime factor tree out, but you do need to find the prime factorization of each. So the process I'm showing you is the same process we'll use for finding common denominators. So for 24, well, first let's find what they have in common. They have a 3 in common, so I'll write that in the middle. And that's all they have in common. And now let's look at 15. 15, we need a 5. And for 24, we're going to need all 3 of those 2's. And I can write it as 2 cubes, or you can write it out, whatever is easier for you visually. So my greatest common factor is 3, but what we're looking for here is both the least common multiple and the greatest common factor. So the greatest common factor is pretty easy. For the least common multiple, do you remember what to do? We're going to multiply everything, right, that we see up here. So we're going to multiply the 5. In the black circle, the 3 that is in the overlapping part, and the 2 to the third, or the 3 2's that are in the green circle. Again, if you need to, you can use your calculator here. All together, that's going to give me 120. So the least common multiple of 15 and 24 is 120. All right, let's move on and apply this idea. So when I'm working with two fractions and I want to figure out what the least common denominator is, I'm going to use the process we just used, but I'm going to write it like this. I'm going to write out the prime factors of each number underneath them, of each denominator. So 15 is 3 times 5. 24 is 2 times 2 times 2 times 3. Now what I'm going to do is I'm going to figure out which prime numbers are missing for the 15 that the 24 has. So for 15, I have a 3 and a 5. Well, 24 has a 3. It also has 3 2's. So I need to multiply this by the 3 2's so that I have everything that the 24 has. And if I multiply by the bottom, I have to multiply by the top as well. Then in 24, I want to look at all the prime factors of 24 and make sure we have all the same prime factors down there that we have for 15. So for 15, I have 3 and 5. For 24, I have the 3 but no 5. So the 5 is what's missing. So I'm going to multiply the bottom and the denominator and the numerator by 5 in my fraction. And what this does is it gives our denominators the same prime factorization. We have a 3 of 5 and 3 2's for both of our denominators now. So both of our denominators will be the least common multiple possible between 15 and 24. So when I multiply that out, I end up with 14 times 2 times 2 times 2, which is really just 14 times 8, which is 112. And then we end up with 3 times 5 times 2 times 2 times 2, which is really just 15 times 8, which was that LCM, or least common multiple of 120. And then for 21 times 5, we end up with 105. And again, our denominator should be the same as in the other fraction, which is 120. And this is how we get our common denominators. Here are the basic steps for adding fractions. You need to get a common denominator. And we already talked about how to do that using the least common multiple. Then you're going to add whole numbers and fractions separately. So we'll add the 6 and 5 separately, then we'll add the fractions. Then you regroup if necessary and simplify all your answers. So I would like to look at this problem and think about getting the common denominator. Now 7 is a prime number, right? So you don't need to factor it, it's already factored. 4 is just 2 times 2. If you have one denominator that is prime, and the other denominator does not have the prime number as one of its factors, there's nothing you can do but multiply the two denominators times each other. In other words, we're just going to multiply by 4 over 4 for our 3/7, and we're going to multiply by 7 over 7 for our 3/4. So we end up with 6, and what's our new fraction? 12/28, right? We end up with 5, and what's our new fraction? 21/28, right? Now we can add. We're trying to figure out how many holes we have. We have 11 holes. And how many 28 pieces we have. 12 plus 21 is what? 33, right? Now what are we going to do since we have an improper fraction? Well, keep in mind that 11 and 33/28, there's an understood plus between the whole number and the fraction. So this is the same thing as 11 plus 28 over 28 plus 5 over 28, right? Because 28 plus 5 is 33. Now, we can rewrite that as 11 plus 1 plus 5/28, which is 12 and 5/28. And this is where regrouping comes from. This is the basis of regrouping. Of course, the way you probably do it is you divide 28 goes into 33 once with 5 left over. So what we're doing is we're adding 1 and 5/28 to our 11 to get 12 and 5/28. Now I'd like you to try the techniques we just learned to use prime factorization for the denominators, find your least common multiple for the denominators, and then add, regroup if necessary, and come back and check. You should have multiplied the first fraction by 5 over 5 and the second fraction by 3 over 3 after working with prime factorization. And then your two new fractions are 3 and 10/75 plus 2 and 24/75, which gives you 5 and 34/75, and there's no reason to regroup. Let's talk about regrouping for just a minute to make sure you understand it. When you see 3.5, that actually means 1 plus 1 plus 1 for the 3 wholes plus a half, which could be regrouped as 1 plus 1 plus a half, because that equals 1, plus 1/2. So this would actually be 2 and 3/2. That could be regrouped as 1/2 plus 1/2 for that second 1 whole, 1/2 plus 1/2 for that third 1 whole. So this would actually equal 1 and 1, 2, 3, 4, 5/2. And of course, if I wrote this as odd halves, where this is our first whole, this is our second whole, this is our third whole, then this would be written as 1, 2, 3, 4, 5, 6, 7/2. This is really important to understand when it comes to regrouping for subtracting, because we're going to have to borrow. Here's pictorially the same idea as what I just wrote out. So when we subtract fractions, you're going to use everything, all the same techniques we just learned, except there will be times you'll need to regroup. So I'm going to start off by getting a common denominator. Note when I get common denominators here using my prime factorization techniques, I end up with my top fraction having a smaller numerator than my bottom fraction, my second fraction. So the way I'm going to deal with this, instead of just changing them to improper fractions, which you could do, but it's just a lot more work when you get to big numbers, the easier way is just to borrow 1 from 26, which becomes 25. And you add that 1 whole to 2 and 2/20. But since we're adding the 1 whole to a fraction, we need to have common denominators, so I'll add it as 20/20. So that's going to give me a new fraction of 22/20. So now I'm subtracting 25 minus 17 and 22 minus 50, which gives me 8 and 7/20.